Okay, let's look at 8 and 9. So solve by factoring. So the first thing I want to do to make my life easier, now since I have an equal sign here, one of my properties of equality is I could just go ahead and divide everything by 2. And so everything here, you can see I'm going to divide by 2. So that first value would simplify into just an x squared, then minus 6x, and then minus 7, and then 0 divided by 2 is still just 0. And now I'm ready to factor this. And basically what we're going to do is we're going to do the opposite of foiling. So if you remember foiling, that's when you have two binomials being multiplied together. And that first term is this right here. The first two values getting multiplied together create that x squared. So that would just be an x and an x. Then the minus 6x is the outer plus the inner being added together. So this times this would be my outer, and this times this is my inner. And then those two things have to add up to minus 6x. And then there's another condition, though, on this, because that could be multiple answers to create a minus 6x. The other condition is that the last two terms have to multiply together to give me a negative 7. So what that tells me is that if I'm going to multiply, so let me, let's see, okay, I was going to try to give myself a little bit more room, but what we're trying to do here basically is try to figure out what two numbers, we'll call them, I'm just going to call them A and B, two numbers that multiply to give me negative 7, but then at the same time, A plus B, these same numbers I'm looking for need to add up to negative 6, because that's what I'm trying to figure out. Two numbers that will multiply together to give me negative 7, but when they get added together from the O and the I part of FOIL, it will add up to negative 6. And so those magic numbers are going to end up being a negative 7 and a positive 1. So I need to put a minus 7 here and a plus 1 here. Now I could do vice versa. I could have put the plus 1 first and then the minus 7. And so anyways, this, I'm almost done because it does say solve. So I need to finish solving this in just a second. But just to kind of review this, see, if you were to FOIL this, the inner would give you a minus 7x. The outer would give you a positive 1x. And that's where that minus 6x comes from in the middle. And then obviously negative 7 times 1 is that minus 7 right there. But they're asking us to solve this. And so they told us to use factoring. And why is factoring helpful? Well, let's think about what they're asking. They're asking us to figure out what value when I plug in for x here and here will cause this equation to equal 0. And that's a pretty difficult task if you really think about it. 2 times some value that we're looking for raised to a power of 2 minus 12 times that same value and then take away 14, and I want to equal 0. If you were just going to sit here and guess and not really have a strategy, that would be pretty difficult. But what factoring does for us is it breaks stuff into multiplication. So these two things, we call them our factors, are getting multiplied together. And what we know is that 0 times any number is going to equal 0, right? So what I do is I take each of these factors and ask myself, okay, well, what would make this factor equal 0? And then same thing with the other one, x plus 1, what would make this factor equal 0? Because if either one of them is 0, the whole thing will collapse and equal 0. So my first solution would be positive 7. And then my other solution is negative 1. And so if you plug in either one of those, they both work. 7 or negative 1, they both work. If you plug it in, it causes this to turn into 0. So then I get 0 times 8, it looks like. 7 plus 1 is 8. But 0 times anything is 0. And then same thing, if I plug in negative 1, this would become a 0, and the whole thing just gets knocked out. Okay, then number 9. It's going to kind of be more of the same. There's a couple different ways to approach this. This problem's definitely much more challenging, and what does that is that we have a 3 in front of the x squared right here. So on number 8, I was able to basically get rid of that 2 by dividing everything by 2. Well, I can't divide everything by 3. That won't make my life easier. That'll actually make things harder because I'd have to have fractions, right? So I'm stuck with that 3x squared. So remember I told you, we're basically undoing the FOIL. So this is my f part right here. So for my two binomials that I'm trying to find, I know that the first two terms need to multiply together to give me 3x squared. And so that's going to be a 3x and x, right? So 3x times x is 3x squared, right? Now this is going to be the trickier part here. Up above, I just had to figure out, you know, what multiplied to give me -7, but add to -6. It's a little bit more challenging here because I have that 3x there. So my outer and inner are not on the same level playing field. So the outer, I'm going to have 3x times, you know, whatever. And then on my inner part, it's going to be x times something. So it's not quite balanced how it was up here. So it's a little bit more challenging. And so a lot of people call this method guess and check. So I do need to come up with two numbers that multiply to give me 8, but then the outer and the inner add up to -25x. Well, there are a couple clues here because I have to multiply to get 8, but the outer and inner add up to a negative value. So what that tells me is my values are going to be negative, right? They're both going to be negative. And so my options are, it could be -1 and -8, or it could be -2 and -4. And those are my only options. But placement matters. Where I place them will determine how the outer and the inner kind of work out here. So I'm a little bit more experienced with this, so I can kind of see that, okay, the -8 is probably going to go here, and I'm going to have a -1 here. And that's because this would give me -1x, and then the outer would give me -24x, which then adds up to that -25x in the middle. So what I've done is we've manipulated this by doing factoring. We factored this to manipulate this to where now I can do the same thing I did on the previous problem. These two things are getting multiplied together, so I'm going to take each one of these factors and just set them equal to 0 and solve. And so then we got x minus 8 equals 0. Now, on the previous one, I just kind of did it in my head. It was pretty simple. And this first one's pretty simple. That's just going to be x equals 8, right? Because you would add 8 to both sides to solve. And there we go. Now, on the other one, though, it's a little bit more complicated. So I'm actually going to kind of go ahead and do it in 2 steps. So I'm going to start by adding 1 to both sides. So then we get 3x equals 1. And then I am going to go ahead and divide both sides by 3. And so I get x equals 1/3. And there we go. Those are my two solutions. Either one of those values, if you plug it in, it will make that equation equal 0. Okay, let's move on to the trig questions. So the first one says, what is cosine of x that will make that ratio equal 2? And it's no solution or undefined. And so what we're going to, undefined, because we're, anyways, let's talk a little bit about the unit circle, because this might make a little bit more sense. So we start right here on the x-axis. That's where we, that's our initial side, always right here. And we rotate around the circle. And what cosine is it's the, it's kind of associated with the length of x. In the unit circle, this distance would be a 1, and as it goes around, this is the radius. But see, the x value it would be currently 1 up here, and then up here would be at 0, and then over here it would be -1, and then down here it would go back to 0. So thinking of the x value if I was at the origin of a graph right here. And so, and you could also look at this as the ratio with SOHCAHTOA. And so, like, for example, let's look at this angle. I'm just going to make one up like this. And so this distance right here would be my x value. This would be my y value. And then we call this the radius. That'll be our r value. And so cosine of an angle, cosine, we typically use theta for angles, would be that's going to be the x value over the r value right there. And that's from trigonometry. And so the thing here is x will never be longer than r. It can be equal to r. It's equal right here if you're looking at an angle of 0 degrees. So cosine of 0 degrees actually equals 1, because the x value is 1 and the radius is 1. So 1 over 1 is 1. So anyways, that's why this is going to be undefined, because you can't go above 1 for a cosine for an angle here. Okay, let's see. Tangent. Tangent right here. Tangent can equal 6. So tangent, let's talk about what tangent is. So tangent of an angle is going to be y over the x value. And so if you look at my example I gave right here, you can see the y value is bigger than the x value. Not by much, but you know, it is bigger. And as I get closer to 90 degrees up here, my y value will get bigger as my x value gets smaller, and so that ratio will get bigger and bigger. So that tangent of that angle equaling 6 is probably pretty close to 90 degrees. It's probably like 80 something degrees. And so we're going to find out in a second. I'm going to have to use my calculator. But before I do that, let me... Okay, I was double checking the direction. They want our solution to be between 0 and 2 pi. So what's going to happen here is that ratio is actually going to happen twice here for tangent being equal to 6. So once again, I'll kind of give you a rough idea of what it should be close to. Oh yeah, and it looks like it wants it in radians, which that's fine. Kind of what I was alluding to, I'm going to give a fresh one here, is the angle is probably somewhere around like 80 degrees, right? But we're going to have to do it in radians. But because that y side needs to be 6 times bigger than the x side. Now that will also occur down here. That would also occur down here. The only difference is my x value will be negative and my y value will be negative. So I'm going to have a solution in quadrant 1 and in quadrant 3. Not quadrant 2 or 4, because that would give me a negative. So if they would have done -6, then we actually would have been in quadrants 2 and 4 instead. But since it's positive, I'm going to be in quadrants 1 and 2. Okay, so I mean, this isn't difficult to do because we're just going to put it in the calculator, but I just kind of wanted to give you a little visual there. So let me see. I'm on degrees. I know it wants the answer in radians, but it's a lot hard. I mean, it's a lot easier to understand this kind of stuff if it's in degrees. So I just want to show it to you in degrees, and then we'll do it in radians in just a second. So I'm going to do the tangent inverse of 6, and it's actually only going to give me one of my solutions. Okay, so we actually have to find the second one. So right there, it gives me 80 we'll just keep it simple, 80.5 degrees. And so that's what this angle is right there. That's 80.5 degrees or so, right? And then what happens is I go another turn right here, which is 180 degrees. And so that's going to be my other one. So I'm going to add 180 to that. And so my second angle that satisfies that number 24 would be 260.5 degrees. So those are my two answers in degrees, but it didn't want the answer in degrees. It wanted it in radians. So let me go back to my calculator. Really, the only difference here is I need to go to mode, make sure I'm on radians, and then when I go back here, I can just retype this in. And let's see, here we go. And I don't remember how many decimals it wanted. Let me see if I have it pulled up. So, does it say? Oh, wait, these are the answers. Okay. Okay, they went 2 decimal places. That's what we'll do. So that'll be 1.41. 1.41 radians. Okay. And then instead of adding 180, because before I added 180 degrees, right? But that is the same thing as adding pi, because the circumference of a circle is 2 pi, so half of that would be pi. So let me go ahead and go back to that. And so what I'm going to do is I'm going to say plus, and then I'm going to do plus pi. And so now let's see, what is that? 4.55. So 4.55 radians. And so those are the two answers to number 24. Okay, then the last one, 25. So remember what cosine is. I have that up here. That's the x divided by r. And so let's talk about what quadrants we're going to see that occur in. So here's my initial side. And so I want a ratio. Basically, my x value needs to be -2, and my y value needs to be 3. Okay, so I know in the unit circle we typically have the y value equaling 1, and I could simplify this fraction to where the y value is a 1, but I'm not going to do that. We're just going to do a rough sketch, and actually maybe I won't do a unit circle so I don't confuse you. Let's look at this as more of like an xy plane. That might make this a little bit easier. Okay, so let's see. So my x value needs to be -2. And then my r value is going to be 3. So I know that I'm going to be going over, let me do a different color. I'm going to go backwards about 2 units. So that's going to be this. That's going to be this. And then that angle could be created 2 different ways. Okay? It could be, so this would, because you always start on your initial side right here on the x-axis. So it's going to be this angle right here, which is more than 90, right? More than 90. But then also, it could be this other angle right here going around to right here. And so that is going to be a little tricky. Because when you put this in the calculator, it's going to give us... well, let's go ahead and see what we get, because we're going to have to be careful. We want to make sure we're within our parameters. So let me clear this out. So we'll do the cosine inverse of -2/3. And so it gave me the first one right there in blue, my blue one right there. So that's 2.30. So let's see. This angle right here is 2.30. Okay. And so in order to get that other angle, this once again, this goes back to your trigonometry class. What's going on here is this going backwards would actually be -2.30, but you don't want to use that, because remember our parameters need to be between 0 and 2 pi, which 2 pi is about 6.28, by the way. You know, there's more to it, but it's about 6.28, and there's a little bit more that falls behind that. So, so that's not within my parameters. I have to go counterclockwise. But what I do know is that a whole revolution is 2 pi, right? A whole revolution is 2 pi. So what I'm going to do is this green part, I'm going to have that as 2 pi, and then I'm going to subtract off this little extra spot right here. So I'm going to subtract off 2.30, and that should give me what that green angle is right there swinging around. So let me go back to my calculator. So I got to put in 2 pi, and then we'll go ahead and subtract 2.30, and so we get 3.98. 3.98. So just, watch the videos, review some of that material. If you need more trig review, let me know. I can maybe we have some more videos that I can share with you, and feel free to send me questions like you did here.